So welcome again guys, welcome again in another video of microbiology with Chagnik. In this video lecture we will going to talk about X-linked recessive trait with the help of a example. Before going to talk about the example, I want to show you the rules that is necessary for the X-linked recessive. You can take a screenshot of that if you want to make notes. Then we will move to the examples, right? So welcome again. So this is your example. Okay, so let's start. First of all, as I have told you, you need to first find out whether it is recessive or not, and the only formula for this is to check whether it is keeping past generation or not. So this is our generation 1, this is our generation 2, this is our generation 3, and this is our generation 4 as usual, right? So the generation 1 simply depicting us that no individual is showing the trait. Okay, now so we can easily conclude that this is recessive one. Okay, and now we need to find out whether it is X-linked or not. For this the main important, and for me the effective formula is you need to find out whether the trait showing sex biasness or not, right? So here 1 2 3 4 4 males are affected, and in contrast one female are affected, so it is 100% showing sex biasness, right? So it is an example of X-linked recessive, but for confirmation you need to do the genotypic analysis, right? So let's do this. So for X-linked recessive there are three. For let's talk about female first. Okay, so there are three possibilities, and here as we need to talk about recessive, and I have told you in case of autosomal recessive that here the heterozygous will be carrier. That means this individual will not show the phenotype, but it have the gene that have the ability to cause disease. Okay, but the expression of this disease gene is masked by the presence of this dominant type. Okay, so this will be the necessary genotype, and for males this is the normal, and this is the diseased. Okay, so let's start. So we can easily assign this. So there can be two possibilities, whether it will be dominant and normal, and whether it have a recessive gene or recessive disease gene, but its expression is marked by presence of dominant normal gene. Okay, so let's find out whether what is the truth. So for this you need to observe that they have a children, they have a male children which is affected. Okay, so it is obvious that excess is not possible, because as the male is normal, that means the genotype is 100% XY, so there will be some supply of XC that makes their son diseased, right? That means the mother's genotype will be XCX. Okay, then let's come here. Okay, so there can be two possibilities, whether it is XCX or XX, or this is XCX or XX. Okay, so let's find out. For finding out you need to do Punnett square XCY. Let's talk what will happen if we take it normal. XCX XY XCX XY, right? So if we consider this female as normal, not carrier, then there will be no diseased son, but they have diseased son. That means this female is carrier, and this and her sister will be then normal type. Okay, so this is XCX XCY, and they have their children. Okay, similarly come here. Oh, so there is now no confusion yet. There is another confusion that you may find, that whether this female is XCX or XX. For make it out, it is easy that as the male is, what I can say, male is normal, so the genotype for that male is XY. Not so, but their son is diseased. That means there must be a supply of XC, and it is absolutely supplied from mother. Okay, so that is the reason why the genotype for the mother will be XCX. So it is the example of X-linked recessive trait. Okay. So I hope it is clear, and if it is, please like my video, share with your friends and subscribe the channel. Thank you.